Okay, let's face it. If you're doing any kind of academic writing, you know the drill.
Oh, yeah.
You're trying to pull everything together, build your argument, but then, the citations, making sure every single one is right.
It's a huge time sink.
Yeah.
Seriously. Just tracking sources, formatting.
Exactly.
Yeah.
And you're trying to stay current, produce solid work, but you feel like half your life is just managing references.
It really can feel like that. And it's crucial, right? That accuracy is the foundation. It's about credit, sure, but also letting people follow your work.
But it's getting harder with just the sheer volume of research out there.
For sure. You want rigor without getting totally bogged down.
Which brings us to today's deep dive, ScholarCopilot. Now, this sounds interesting because it's not just, checking grammar.
It's aiming higher.
It's supposed to help generate coherent text and pull in the right citations as it goes, like a smart assistant that actually gets the research process.
Kind of like a shortcut, maybe, to well-supported writing without all that manual citation pain.
So we're diving into the paper behind it today. We want to figure out, does this thing actually work? Could it genuinely help make academic writing less painful?
Yeah, we'll look at how it's built, what it does differently, and importantly, where you still need that human brain.
Right, because some of the claims, I have to say, were pretty surprising when I first read about them.
Well, it tackles a big problem head on. Those hallucinated citations you get from a lot of current AI models.
Oh, tell me about it. The big ones like GPT-4, DeepSeek, Quinn, they can write beautifully academic text.
Incredibly fluent.
But then you check the references and they're just made up or completely irrelevant.
Exactly. Which makes them basically useless for serious work where accuracy is everything. You just can't trust them for that critical piece.
Right. You get this perfect paragraph, think yes, and then poof, the sources don't exist. It's maddening.
It really is.
So the ScholarCopilot folks looked at what people were already trying, like Retrieval-Augmented Generation.
Yeah, RAG. The basic idea there is, okay, let's find some relevant papers first, and then give that info to the language model to make its writing more factual, more grounded.
So it has some real knowledge to work with.
That's the principle. But the paper we're looking at argues that traditional RAG has some, significant limitations.
Okay, like what?
Well, one big issue is that finding the information, the retrieval part, and writing the text, the generation part, are often treated as totally separate steps, optimized differently.
Ah, okay.
And that can lead to this representation misalignment. Basically, what the retriever thinks is important might not be exactly what the generator needs right then.
Gotcha. Like two different teams not quite on the same page.
Pretty much. And another thing is that the retrieval is often done up front, like one big search before the writing really starts.
Right. Okay. So it's not very flexible.
Exactly. It lacks flexibility and context awareness. The paper uses a good example. Say you mentioned GPT-4 in your intro. A traditional RX system might have already done its search and might not be able to dynamically grab the best GPT-4 references right at that specific moment you need them.
Yeah, I can see that. It's like you gathered ingredients for one recipe, but then decided to tweak it halfway through.
Perfect analogy.
Yeah.
And that inflexibility also means less control for you, the writer.
Right. If the system decided the relevant papers at the start, it's harder for me to say, no, actually, I need this specific paper cited here.
Precisely. You might have a key study in mind, but the system might not surface it when you need it because of that static pipeline.
Okay, so that's where ScholarCopilot tries to be different.
Exactly. This is the core difference.
They call it an agentic RGRAG framework. What does agentic really mean here?
It means it's more active, more involved in the writing process itself. Instead of retrieve, then generate, it weaves them together. It's iterative.
How does it do that?
The key innovation is how it decides when to look for a citation. It actually generates special markers. Tokens, they use RET in the paper right within the text it's writing.
So as it's writing, it thinks, a citation would be good here, and puts in RET flag.
Basically, yeah, based on the context of what it's just written.
Yeah.
And when it generates that RET token, it pauses the writing for a moment.
Okay.
Then it uses the text generated so far to search its database of papers. And crucially, it pulls in not just titles, but maybe abstracts or key bits of text from those papers.
And feeds that back into the writing process.
Exactly. It integrates that retrieved info as it continues generating. That's what makes it context aware. It's finding citations because of the immediate context right when they're needed.
That sounds much more dynamic. The paper had some figures, right? figures 1 and 2.
Yeah, those visuals really help contrast this iterative flow with the more rigid traditional RAC. It's a much cleaner picture.
And they mentioned using contrastive learning for these retrieval tokens. What's that about?
That's about making the retrieval super efficient and accurate. Think of it like teaching the system to create a really good fingerprint for the need for a citation at a certain point.
Okay.
Contrastive learning helps make sure that fingerprint is very similar to the fingerprints of relevant papers and very different from irrelevant ones. So when it generates our RET, the search is much more likely to hit the right target.
Makes the search smarter.
Much smarter, yeah,
Right.
for finding the best matches quickly in that huge database.
And it's not totally automated, right? The user still has some input.
Absolutely. That's key. It's designed to assist you, not completely take over. You can optionally step in, trigger a citation yourself if you have one in mind, or refine what it suggests.
So it blends the AI with human expertise.
Exactly. That iterative interaction is built in.
Okay, this all sounds great in theory. How did they actually build this thing? The paper mentioned a lot about the data they used.
Right. They needed a massive specialized data set. They focused on computer science papers from arXiv,
Okay.
pulled something like 670,000 papers initially, covering almost 2 decades, like 2007 to 2024.
Wow.
Then they needed the source code, the LaTeX files, to really parse the structure properly. They got that for about 570,000.
That's incredible.
Yeah. And then they built tools to break down those LaTeX files, pull out the title, abstract, intro, related work, and crucially, the bibliography. After cleaning it up, they had around 500,000 structured papers for training.
500,000 papers. And then they had to figure out which paper was which in all those bibliographies.
Precisely. Extracting the cited titles accurately was tricky because formats vary so much. Simple pattern matching wasn't cutting it.
Yeah, I can imagine.
So, interestingly, they used another smaller language model, Qwen 2.53b Instruct, just for that task, reliably pulling out the titles from the bibliography entries.
Using AI to prep the data for the bigger AI. Clever.
It worked well. They got about 19 million unique citation titles identified that way.
19 million. But just titles aren't enough. You need the actual paper content for retrieval later.
Exactly. So the next big step was reference matching. Taking those 19 million titles and linking them to actual entries in databases like arXiv and Semantic Scholar.
Okay, connecting the title to the real paper.
Yep. They managed to match about 16.8 million citations successfully. Figure 3 in the paper lays out this whole data pipeline nicely.
So, on average, how many citations per paper did they manage to link up?
It averaged around 33 matched citations per paper in the training set, which is about 87% of the citations listed. So a very rich, interconnected data set.
Okay, massive data set ready. How did they train ScholarCopilot to do both the writing and the citation finding together?
They use what they called a unified training framework, basically teaching the model to juggle 2 tasks simultaneously and making sure they work together.
Juggling.
Yeah, it's learning to predict the next word, like a standard language model. That's the generation part. And at the same time, it's learning to create those effective fingerprints for the RET tokens using contrastive learning. That's the retrieval part. Figure 4 shows this architecture.
So it learns both at once.
Right. The generation part uses a standard method, predicting the next token based on history and retrieved info. They call the formula for this LG the generation loss.
And the contrastive loss for the retrieval tokens. Oh, how does that one work?
That's the fingerprint training we talked about. It pushes the fingerprint of a RET token, they call it Q, closer to the fingerprints of relevant papers and further away from irrelevant ones.
Pushing and pulling based on relevance.
Exactly. Using math like cosine similarity to measure how alike they are. And they had a smart way to pick those irrelevant negative examples, using other citations from the same paper that weren't relevant right there as hard negatives and citations from totally different papers as easy negatives.
That sounds quite sophisticated, and they had to balance these 2 training goals.
Yep, they combined the losses. L total, LG plus, OR, lambda, L sala, just a weight. They set it to 1, basically saying generating good text and retrieving good citations are equally important.
Okay.
This joint training is really the secret sauce, making sure the model learns to use those RET tokens effectively without messing up the writing quality.
All right, so they built it, they trained it. How did they test if it actually worked well? What were the evaluations like?
They tackled evaluation from 2 angles: generation quality and retrieval accuracy.
Makes sense.
For generation quality, they actually used GPT-4o as the judge.
Using an AI to judge another AI. Interesting.
Yeah. They had GPT-4o score text from ScholarCopilot and other models on 5 things: relevance, coherence, academic rigor, completeness, and innovation, each out of 5 points. They used 1,000 writing samples for this.
And how did ScholarCopilot stack up?
Pretty impressively, actually. Table 1 shows the results. ScholarCopilot got 16.21 out of 25 overall. That was significantly better than comparable models, even much larger ones like a 72 billion parameter Quinn model.
Wait, ScholarCopilot is smaller. How small?
With 7 billion parameters. So it was punching well above its weight class, especially on relevance and coherence, where it nearly matched the giant models that were even fed the correct citations during training.
Wow. So the integrated approach really paid off in generating relevant, flowing text with the right support.
It seems so. For the listener, the takeaway is this approach seems genuinely better at producing text that sounds right and is right, citation-wise, even compared to much bigger models. Could save a lot of verification time.
Okay, that's generation. What about finding the right citations, the retrieval accuracy?
They used a standard metric, recall at K. Basically, does the correct citation show up in the top K results? They looked at K, 1, 5, and 10.
So is the very top result correct, or is it in the top 5 or top 10?
Exactly. They tested this on 1,000 examples where they hid the original citation and made the models predict it. Figure 5 has the numbers. ScholarCopilot hit a top 1 recall of 40.1%.
40%? How does that compare?
Way better than the baselines. BM25, a classic method, only got 9.8%. Another model, E5 Mistral, got 15.0%.
So more than double the accuracy of finding the single best citation.
Substantially better, yeah. And its recall at 10 was 64.8%. Again, much higher than the others.
Okay, so what does that 40% top 1 recall actually mean for someone using it?
It means if you're hoping the system nails the single most relevant paper for that spot, ScholarCopilot has a much, much better chance of doing that compared to older retrieval methods you might have encountered.
That's a big difference. Why do they think their unified approach works so much better for retrieval?
Their thinking is that by training generation and retrieval together, the model learns the underlying reason or intent behind needing a citation in that specific context.
Ah, not just keywords.
Exactly. Traditional methods rely on explicit search queries, which might miss the nuance. ScholarCopilot generates the need, RET, from the flow of writing itself. So it seems to have a richer understanding of why a citation is needed right there.
That makes intuitive sense. The paper also looked at whether using the content of the retrieved papers helped the writing, right?
Yes, an ablation study. They compared the standard ScholarCopilot, which sees the abstracts or excerpts of retrieved papers, to a version that only retrieved the titles but didn't get the content.
What did they find?
Table 2 shows this. While things like relevance and innovation were similar, the standard version, the one that saw the content, scored better on coherence and academic rigor.
So seeing the content helps it write better.
Seems like it. The analysis suggested it helps avoid mistakes when discussing the cited work and improves the overall flow, especially when comparing ideas or transitioning. It has more context to work with.
They had that example about transformer models, didn't they?
Yeah, exactly. The standard version, having seen the content of the famous attention is all you need paper, could make a more specific point about multi-head self-attention and cite it correctly.
Whereas the version without the content
made a much more generic statement about self-attention. So seeing the content leads to more precise and well-supported writing. For the user, that means potentially more accurate summaries or discussions of related work.
Okay, so the automated tests look good, but they also got real academics to try it out.
They did. A user study with 10 participants, all with academic writing experience. They asked them to use ScholarCopilot for introductions and related work sections in their own fields.
And gathered feedback.
Yep, both ratings on a 5-point scale across 15 different metrics, things related to citation quality, user experience, content quality, and also open-ended qualitative comments.
What did the ratings show? Were users impressed?
The quantitative results are in Figure 6a. It scored highest on citation accuracy, 4.6 out of 5, which is really strong.
Nice.
Also high scores for interface clarity and writing style, both 4.5. Overall, citation quality averaged 4.3, which is very solid.
What about user experience and content?
User experience averaged 3.9. The main drag there was response time, which got a 3.3. The researchers think that was mostly down to their server limitations during the study, though.
Okay, so potentially fixable. And content quality?
A bit more mixed. Factual accuracy and writing style did well, but innovation got the lowest score, only 2.5.
So great for accuracy and style, less so for generating brand new ideas. That kind of makes sense.
It does align with where AI often excels and where it still struggles.
How did it compare to something people might actually use now, like ChatGPT?
They did a direct comparison, shown in Figure 6b. ScholarCopilot came out favorably overall. The biggest difference was citation quality. 100% of users rated ScholarCopilot better than ChatGPT.
100%. Wow.
Yeah, that's a clear win. For overall usefulness, 70% preferred ScholarCopilot. Writing quality was closer. 50% preferred ScholarCopilot. 40% found them similar.
So a definite edge, especially on the core task of citations. What did users say in their comments? What were the pros and cons?
They really liked the integrated citation management, having it right there in the writing flow. Also, the interactive style, feeling like they were collaborating with it. And many saw potential for saving time, especially on related work sections.
Sounds positive. Any suggestions for improvement?
Yeah, common themes were wanting it to generate more comprehensive or longer pieces of text, needing faster response times, and echoing the ratings, wishing it could help more with generating truly innovative ideas or research questions.
Makes sense. But overall, would they use it again?
It seems so. The average rating for likelihood of future use was 4.1 out of 5. So, despite the areas for improvement, they saw real value there.
Okay, so it sounds like a promising step, but the researchers themselves admit it's not perfect yet. What are the main limitations they point out?
Well, right now, it's mainly built for introductions and related work sections. It's not designed for, say, methodology or results yet.
Got it.
And the training data was all computer science papers, so its knowledge is limited to that discipline currently.
Right, not ready for history or biology papers just yet.
Not yet. And as the user study showed, generating truly novel insights is still a big challenge for AI in general.
So what are their plans? Where do they see this going?
They have a clear roadmap. First, expand it to cover other paper sections, methods, discussion, etc., and also broaden the disciplines beyond just CS.
That would make it much more widely applicable.
Definitely. They also want to experiment with bigger, maybe more advanced AI models and different training techniques to try and boost creativity and innovation.
Tackling that innovation score.
Exactly. And finally, just keep improving the user experience, maybe persistent storage so you don't lose your work, better summaries of references, and making the system faster and more robust, especially if lots of people start using it.
Okay, great. So let's wrap this up. What's the big takeaway for our listeners from this dive into ScholarCopilot?
I think the main thing is that this represents a really significant step forward for AI helping with academic writing, especially that huge pain point of accurate citations.
Right.
It shows a way to potentially make the whole research and writing process more efficient and reliable by smartly integrating citation finding right into the writing flow.
And the real aha moment, the key innovation.
For me, it's that dynamic, iterative integration. The idea that the writing itself triggers and shapes the search for citations in real time. That seems to be the breakthrough that overcomes the stiffness of older arXiv systems. It's much more fluid, more context-aware.
But it's important to stress it's still a tool, right? Not a replacement for the researcher.
Absolutely not. Especially for the core tasks of critical thinking, original insight, finding those truly novel connections that's still very much the human's job. This can help with the scaffolding, the accuracy, the efficiency, but not the deep thinking.
So a powerful assistant, but you're still the lead researcher.
Precisely.
Okay, so here's a final thought to leave our listeners with. Seeing how fast this field is moving, how might tools like ScholarCopilot change the whole game for academic research, and how we create knowledge down the road?
Ooh, good question.
Think about your own field, your own work. What could the impact be? It's definitely something to keep an eye on.
For sure. Exciting times.